stuff. So, I think the first thing I need to do, actually I'll be quiet. What do you do?
Well, you gotta look for domain restrictions.
You guys, did I change the question? I'm sorry. Is it really just x root x plus 1?
It's x plus 3 squared. Yeah, over x minus 1.
So, I'm so sorry. You know, my answer sheet, I mixed them all up. So, can you give it to me from scratch? I apologize.
It's
Oh.
parentheses x plus 3 squared.
All over.
X minus
Okay, first things first. No calculus. Let's just talk basic algebra. Yes or no response. Is negative 3 a 0th the numerator? Is negative 3 a 0th the numerator?
No. Yeah.
Yeah, so who cares? What does that tell you about the graph? Say a little louder. A little bit louder. Because well, think about it, watch. When you plug negative 3 in for x, not only is this numerator equal to 0, the whole fraction is, it gives me a y value of 0. And so I think the zeros of my numerator are going to give me the location of my x-intercepts. Do you guys agree this is an example of a rational function, a function which is expressed as a ratio of two integers? Excuse me, a function which is expressed as a ratio of two polynomials? It's a rational function. Yes or no response. Is positive 1 a 0 of my denominator?
No. Oh. Sorry.
It's okay. I think it is. I think it is. And what does it tell you about the graph?
Undefined.
What kind of asymptote? Davey, you're right. It means my function's not defined there, but because it's a rational function, I think that gives me the location of a vertical asymptote. And so I think I've got a vertical asymptote right here at x equals positive 1.
I got that one.
Good. We're on track. How do you find y resist for any function? Put 0 in for x, solve for the corresponding y value. And if I plug 0 in for x, I think I immediately get 0, negative 9. Shoot, you guys, what have I just done? I found all the x-intercepts, I found the y-intercept, I found the vertical asymptotes. Now let's find the non-vertical asymptotes. How do we do that? I think in this example it's going to be an oblique or slant asymptote. Because as a rational function, the degree upstairs is exactly one more than downstairs. Given that there's a non-vertical, non-horizontal oblique asymptote, how do I find it? Polynomial long division versus synthetic division, if you prefer, it's entirely up to you. Well, pulling out a nifty piece of scratch paper. If I divide my denominator into my numerator, which is x squared plus 6x plus 9, let's just deal with it. I think when it comes to polynomial long division, it's merely a game of paying attention to leading coefficients. I misspoke. I meant leading terms, not leading coefficients. Great?
What are we trying to find right now?
I'm trying to find the oblique asymptote. I'm trying to find that non-vertical, non-horizontal line to which my curve is going to hug arbitrarily close to at extreme values of x.
That there's one y.
And I know there's one because when I look at the polynomial upstairs, it's of degree 2. But my polynomial downstairs is degree 1, and whenever the numerator is exactly one more in degree than my denominator, I've got one of those oblique asymptotes. So, let's unite perform some polynomial long division. This is a game of concentrating on leading terms. I think this leading term in my divisor's position goes into the leading term in my dividend's position how many times?
X. Can't see.
One time.
You can't see, my apologies, Christian.
X time.
I think it's x times. Let me rephrase the question. What the heck do you multiply this leading term by to get this leading term?
X.
And therefore, I think x is going to be the very first term in the quotient's position. Paying the consequence of my actions, however, x times my entire divisor gives me a product of an x squared minus x. Now, subtracting the second line from the first, how many x squareds are left over?
0.
None of them.
Oh, sorry.
None of them. As desired, and if there was some left over, that means I made the wrong decision the first term of the quotient position. I said x squared. Ooh, okay. 6x minus 1x is 5x or negative 5x? 7x. Good, neither. I'm subtracting the second from the first, and if you forget that, just go back and say to yourself, how do I get rid of the x squares? By subtracting them. So I know I'm going to be consistent with the subtraction operation. Bless you. And so I think 6x minus a negative x is really a positive 7x. I'll drop the next term. Let's play the game again. Leading term of the divisor's position goes into the leading term, and what the heck is left over? How many times?
7.
I think 7 times. And 7 times the entire divisor gives me a product of 7x minus 7. The difference is which is?
16.
Who cares?
Yeah, I'm just looking for the quotient, right? Brandon? Um,
How was it looking? What happened?
I was just saying I was too lazy to look at the difference, but I'll deal with it.
But it doesn't matter.
Did you see why?
Uh,
Okay, but let me explain why then. Because I think when it comes to this ratio, it should be equal to the sum of my quotient with the ratio of the remainder to my divisor. And so, Brandon, the reason why when it comes to oblique asymptotes, I don't care about the remainder is because I'm looking at what's going on with really, really big values of x. And I think when x is really, really big, this whole fraction of values to what kind of number?
0.
Yeah, pretty close to 0. And so I think when x is huge, this particular fraction is not really important. I just think everything's dominated by the quotient. That's why I maintain that the line y equals 7, or excuse me, x plus 7, is the location of my oblique asymptote. You guys, I know I'm a little off scale. You get the idea. And next, wow, look at all this work I'm doing, no calculus. Next, if I were to build a sine graph of my y values to see when I'm positive, when I'm negative, to see when I live above and below the x-axis, I will barely plot the zeros of both my numerator and my denominator. Do you see why? Because I think with a rational function, it's about either side of a vertical asymptote, I might be changing my y values from positive to negative, or vice versa, or maybe not all. And I think if this is the x-axis, and here's an x-intercept, I think it's about an x-intercept, I might be crossing the x-axis with my curve, and therefore changing from positive to negative y values, or vice versa, or maybe neither. That's why I plot on my real number line the zeros of both upstairs and downstairs, and it's just time to check. I don't want to. I'm beating that clock. I already found that when x is 0, y is negative, so I'll just put a negative sign right in here. I'm still too tired. I don't want to do any work. Notice how this is a 0 of a linear factor downstairs raised to an odd power. It's going to act as a toggle switch. I get a sign change. Here I think is a 0 of a linear factor upstairs raised to, well, look at that, an even power. I'm not going to get a sign change. What the heck does this tell me? I think it tells me a lot. It says I live above the x-axis to the right of 1, but I live below the x-axis to the left of -3, or when I'm between -3 and 1. Now before I put all this together, let me dive in and compute the first derivative function. I can't. Help me with this, you guys. Is y equal to x plus 3 squared over x minus 1?
Yes.
So if I'm going to now differentiate using the quotient rule, I have what's downstairs as is, times the derivative of what's upstairs, which by the way is not bad. Minus what's upstairs as is, times the derivative of my denominator, which is just 1, all over my denominator twice. Let's see how fast you guys can FOIL out. Let's see how fast you can FOIL out. Now, let's not do it. I got 2 terms upstairs, each of which has a common binomial factor of
X plus
just
3.
pull it out. Make my life easy. And if I pull out an x plus 3 factor from upstairs in both terms, I think what the heck remains standing on either side of the subtraction operation is a product of this constant with this binomial and this binomial. And you guys, in continuing to clean up, I think that means that y prime is equal to x plus 3 times something all over x minus 1 squared. I just got to deal with what the heck that something is. And taking a peek at the something, I really don't know what it is. Is that a single x? Minus 5, I think? Please just double check my arithmetic. Oh, please let this be erasable. Oh, oh shoot, what does that tell me? Perfectly put. These are critical numbers, critical values. They don't necessarily yield the local extrema. I gotta check them. So building myself yet again another nifty number line, I will plot the zeros in my numerator, as well as a 0 in my denominator. And if I plug something like 1 billion in for x, clearly all 3 of these are positive. It's just that this particular real number, the 5, is a 0 of a linear factor raised to an odd power. Sign change. Oh, look at that. Another non-sign change, like before. But this will give me a sign change. Does this mean I live above or below the x-axis? Neither. Neither. It really means the original function was increasing over the interval, decreasing over this one, decreasing over this one, and increasing over this one. See how fast you guys are. I never asked for inflection points. In fact, that happened a lot in this exam. I was just trying to reduce the size down a little bit. A lot of them just dove in and just automatically differentiate all over the place. So I don't want to waste my time.
How did you draw in the oblique asymptote over there?
Can you say a little bit louder?
How did you draw in the oblique asymptote?
I didn't do a very good job. To be honest with you, what I should have done, Brandon, is this. I should have said, oh, here's 1, 2, 3, 4, 5, 6, 7. And I see that 0, 7 is the y-intercept of that asymptote, that line. But the slope is positive 1, so I go down 7, go over 7. I did a poor job. Gotta count something. So you guys, let's see if we can put things together. To the left of this x-intercept. Oh, I've lost it. Oh, here it is. My y values are all negative. But I gotta have this oblique asymptote. I think I behave something like this in purple. Now, to the right of that x-intercept, I'm still negative, so it looks like it bounced back down and won't pass through. As a matter of fact, I got to pass through the y-intercept, and actually look at this. I got to hook that vertical asymptote. Now, on the other side of the vertical asymptote, my y values are all positive, and so I'd probably do something like this. Do you agree?
Nope.
No, I don't agree either. Number one, I'm not positive. Number two, I would have found another x-intercept. Do you guys see my point? So I guess I don't do that. But maybe I do this. Hug the vertical asymptote and hug the oblique asymptote. As a matter of fact, if I did this, looks to me like I probably have some kind of local min y value. And let me just double check my sign graph for the first derivative function. Oh, let's see. It looks to me like I got a local max at x equals -3. Look at the picture. That's what I'm depicting. It also has to be an x-intercept. It's just that to the right of that vertical asymptote, notice I changed from decreasing to increasing about x equals 5. So, I guess this particular local min really does occur at a point whose x coordinate is positive 5. And to find the y coordinate, just plug 5 in for x. And what do you think I'll get?
Plug in the original.
A mistake. Yeah, I got to plug in the original. That's what gives me the y values. But that actually gives me 64 over 4, which is 16. Ah, look at that. There's my local max. I misspoke, sorry. There's my local min.
How did you know to look for the slant asymptote?
I knew for free there's going to be one because this is a rational function, the ratio of two polynomials, where the degree upstairs is exactly 1 more than the degree downstairs. Did you see that? Be honest.
I don't remember that.
Oh, really?
I mean, I see the vertical asymptote,
Yeah, I think that's the easier one to see. So whenever you have a ratio of two polynomials, the degree upstairs is exactly 1 more than downstairs, you do have an oblique asymptote, and you always find it the same way. You perform Pauli-Long division. Or you can use a shortcut synthetic division, if it applies. But that quotient, right over the x plus 7, will give me the location of that oblique asymptote.
Can you use limits to find that?
You know, in a sense, I think it's limits that justify why x plus 7 is actually the location of the oblique asymptote. I'm hesitant to say you can use limits to find the x plus 7. That's why I relied on Pauli-Long division instead. Because to me, the bottom line is this. It's sort of like way back in the 2nd grade. You didn't take the 2nd grade seriously. It was back when math was easy. I think this math is just as easy because check this out. Watch. To rewrite this improper fraction as a mixed numeral, don't just perform Pauli-Long division. 7 goes to 22 3 times. With 1 left over the divisor. And I think when it came to this expression right here, it behaves exactly the same way. What you see inside this purple circle is acting as my 3, my quotient. When it comes to this remainder upstairs, that's exactly where this thing came from. And this divisor is nothing more than my divisor over there. It's behaving exactly the same way, I think. And all I'm really doing here is I'm rewriting this improper rational expression as a sum of a polynomial and a proper rational expression, because the degree upstairs is less than downstairs.
I never saw that one.
You've never seen that?
What happens when the degrees are equal?
Then you get a horizontal asymptote located at the ratio of leading coefficient upstairs to downstairs.
Equal. And what happens when it's more downstairs?
Then you have a horizontal asymptote for free at the line y equals 0. which is the x-axis. Come on, you guys, shake me up. Is that okay? Yes.
Can I just throw out another problem after this one?
Yes.
Number 7.
On the exam. Brad, I'll still get there.
Huh?
I'll still get there.
Oh, yeah, that's fine.
Number 5
So 5 and 7.
is 8.
5, 7, 8.
So, can I ask a quick question?
How about the
So, if you're taking the inverse secant, I know you didn't mark me wrong for this, but aren't you always supposed to do absolute value here? No? That's what the book says.
No, you better not.
It does.
No, it can't.
Doesn't it? I mean,
No, because if I were to differentiate inverse secant of,
e to the 2x squared minus 3.
if I were to differentiate this,
Yeah.
I think I should get this. Gosh, how does that go, you guys? It was 1 over
Yeah.
the absolute value of your x, or in this case, the input,
Yeah.
times the square root of that thing squared, minus 1. It's just that, and I know I'm missing something, I gotta play the chain more.
Oh.
It's just that since e to any power is always gonna be positive, I wouldn't put it in.
Oh, okay.
I think there's inferred.
Is it
No, it's not
wrong
wrong.
if you put
It's
it
just
in?
not
Or
as
is it just,
aesthetically pleasing to the eye. Why would you be redundant and say something twice? You wouldn't want to do that, would you?
So then you can cancel out the.
Well,
Yeah, you guys, I'm not done, am I? I mean, technically speaking, don't I have to apply the chain rule?
yeah.
I mean, now I gotta multiply by what the heck I'm sorry, I misspoke. Now I gotta multiply by the derivative of what the heck I was taking the inverse secant of, but that would just simply do this. Oh, but shoot, now I gotta multiply by the derivative of what the heck I was raising e to the power of, that'd be this. Oh, but shoot, now that I got rid of the absolute value bars, you recognize that indeed, these two factors are equivalent. They cancel.
So why were you able to take those off again? If you were to.
Well, because I think e raised to any power is always positive, no matter what x is.
Oh, yeah, okay.
So why be redundant and put the absolute value bars in?
that's how we memorize it.
Don't memorize anything. You're smiling, Brad, is that okay?
Yeah, that's fine. That's fine.
Could you also really quickly just do 1i while you're at it? Please? Because I introduced it and there's something where I'm missing.
So cosine inverse tangent x cubed equals cosine inverse tangent, I lost it, is x cubed?
Yes.
So diving in, y prime, well, let's differentiate the outermost function first. Negative sign. You guys tell me what to write next. How do I differentiate inverse tangent?
You don't.
You don't, it stays the same. Times the derivative of the innermost, talk too fast again. Times the derivative of the next innermost function, which I think is the inverse tangent function, but to differentiate the inverse tangent of anything. Doesn't that give me 1 over 1 plus the square of that thing? Oh shoot, I'm still not done. Now I gotta multiply by the derivative of what I was initially taking the inverse tangent of, but that would just be a 3x squared. So, I guess in the end, that leaves me with a 3x squared over 1 plus x to the 6th. Oh yeah, wow. That's too strong.
But it works so well.
It works for you. I gotta breathe it. So negative, oh, I'm sorry, the negative sign, got it. What else?
You'll just multiply it by negative sine of the tangent.
Yeah, I know. So what would that look like?
I don't know.
So x cubed over. Anybody? Okay, don't listen to me. Do you guys agree that's an angle?
Yes.
Yeah, it is. I'll give it a name. I'll call it theta. And if I were to embed theta in a right triangle, to say that its tangent's x cubed, doesn't that mean the ratio of this side to this side is x cubed to 1? Now, using my Pythagorean theorem, doesn't that tell me that the length of this leg over here, or this hypotenuse, is nothing more than this? And so I guess in the end, I've got to multiply by the sine of that inverse tangent angle. I gotta multiply by the sine of this particular angle, which is just a ratio of x cubed to the square root of 1 plus x to the 6. But that's just gonna give me a negative 3x to the 5th over 1 plus x to the 6 to the 3 halves. Did you guys think it's too much work?
Definitely didn't see that.
Oh, I was hoping you didn't see this. I didn't want you to do any of this. It's way too much work. Here's what I was really expecting from you guys. What's the first thing you do before you use calculus? Yeah, Math B, or how about in this case, Math 8? I would have just said, the heck with it. I think that angle embedded in a triangle again has this quality. I think the hypotenuse still exists. It's just that, no calculus. I think the cosine of an angle in question is nothing more than 1 plus x to the 6 to the negative 1/2. And I can differentiate in one step, piece of cake. Negative 1/2, 1 plus x to the 6 to the negative 3 halves, all times 6x to the 5th. It's the same thing I have over here. It's a lot less work. That's what I'm saying. Use your Math B skills, or in this case, Math 8 skills, prior to calculus. Same answer, just a heck of a lot less work. Giselle?
Why did the sign disappear? 'Cause
It didn't disappear. When it comes to this red factor right here, everything inside my red box is nothing more than what's inside this red box. Because Giselle, I think this purple thing above the black brace is just an angle theta. And I was just asking myself, what's the sign of an angle theta? Well, in my picture, I think the sign of that angle is opposite over hypotenuse, and that's exactly where this opposite over hypotenuse came from. Do you see it? Okay. I just maintained way too much work. Just do it initially. It'll be so much better off. Okay, if nobody wants to argue with me. You know what? My exam's off. What is your number on?
Actually, no, never mind.
Number 7 now?
So number 7. Oh, I was hoping that would work out so well, number 7.
Oh, that's what
So if you guys aren't sick and tired of hearing about my Chaparral's, he is 2 feet tall.
Is that standing?
What's that?
Is that standing or sitting?
Well, it was fictitious of sitting.
It says a cat.
And there's a lamppost 15 feet tall.
There's a small bobcat.
So he's walking towards a lamppost at a certain rate. I want to know how fast. Brad. So I'm just wondering if this quantity right here is like an x, and this quantity is a y. I want to use an answer. Are both these quantities changing as time goes by?
Yes.
Yeah, I think they are. As a matter of fact, I even think I've been given the information that he's walking towards a lamppost at a rate of 2 feet per second, so I think that means dy dt is nothing more than negative 2, because it's decreasing. So why don't you and I dive in and let's find dx dt. And to find dx dt, I think it's too difficult to build an equation involving it. So I give up. I'd rather just build an equation involving x related to something else and differentiate implicitly. And when you guys take a peek at this picture, do you think it would be worth our while to pull out of our back pocket the Pythagorean theorem?
No.
Yeah, I don't think so either. Number one, I'm not given any information about it. I don't know how fast it's increasing or decreasing in size. However, I do think there's a way I can write an equation relating y to x, namely by looking at
Similar triangles.
what's similar triangles? What's similar triangles?
The 2 to the x and 15 to the x plus y.
How do you know they're similar?
Because they share the same angle.
angle.
Well, I need more than one pair of angles that are congruent. assume that both my cat and the lamppost are standing straight up tall, meaning they're meeting the ground perpendicularly. And I think both the small right triangle and the large right triangle have in common this interior angle, and therefore by AA, those two triangles are similar. High school geometry. And if those two triangles are similar, it means the sides are proportional. Proportional. And so I think the ratio of the horizontal leg of the small triangle to the horizontal leg of the large
X plus 1.
is going to be the same as the ratio of the vertical leg of the small to the vertical leg of the large. And look at that beautiful equation. This is one equation, it does two unknowns, and I can relate them. Actually, let's now differentiate. And differentiate with respect to x, what do I do? Yeah, I'd be diving into doing too much work. That would require the quotient rule, wouldn't it? Wouldn't it be easier to first use your math D skills, clean up the equation, let's get rid of fractions. Let's bring all the terms involved in the variable x to one side. Oh, that looks so clean. I'll stop. Now I'll go ahead and differentiate with respect to time t, because like you guys agreed, x and y are both changing with respect to time. And I see that 13 dx dt is equal to 2y dy dt. I think I misspoke. I meant 2 dy dt. I think I put a y in there when I said it out loud. Now that I differentiate, I can take out my mathematical camera, take a snapshot in time, and identify what these quantities I need. I think I've got dy dt is equal to -2. But that means 13 dx dt is equal to 2 times -2, or shall I say, dx dt is equal to -4/13.
We're not done, right? We have to add.
Yeah, I just ran amok with too much mathematics, you guys. I think I just, I need to go back and realize what the question really is. The question is, how fast is the length of the shadow changing?
You have to add dy.
Wait, did I say that correctly?
How fast is shadow changing at
He's 10 feet away.
Oh,
And then y equals 10.
you know what, you guys? I'm being honest. I wonder if I graded your exams incorrectly. I'm going to chase up my own questions. I was assuming the question was, how fast is the tip of the shadow moving? I'm not done. But you know, now that I'm looking at the question, how fast is the length of the shadow changing, I think I have answered the question. Did I grade you wrong for that?
Yeah, you took
Yeah, I kind of worried I did. I have it in my memory that I was really grading on you adding the 2 units, whatever, feet per second. If I did, I'm so sorry, you guys. I really made that mistake. So I'll fix it. I'll fix it. Oh no, did I make another mistake? There's no 10 feet to put in. I said, oh no, did I make another mistake? There's no way to put 10 feet in.
Doesn't matter.
It doesn't make any difference. It's just a red herring. It just doesn't matter what the length is, or excuse me, what the length of y is. You guys, have I answered the question? Alright. Someone said number 8. Oh, we had 5. Oh, number 8 was a nice question. I'll make some room in the middle. Oh, Brad, I've already erased your question. Sorry, I'll come back.
This is 45.
Well, in number 8, let's see. I've got this nifty little triangle here. I got an angle down here that measures 30 degrees. I've got a mouse here at this position, and it's moved to this position. Oh, by the way, if here's where my cat is, this distance right here is 5 feet. Well, let me slow down and make sure I'm reading my own question correctly. All right, here goes. The mouse is moving in this direction at 2 feet per second. So after 10 seconds, I want to find the rate at which d is changing with respect to time. I'm trying to find dt. Well, here too, like my last example, you guys, I think it's required of me to first build an equation relating d to something else, then treat it as a function of time, then differentiate implicitly with respect to time t, and then put in everything else I know. And so taking a peek at my picture, since this particular length is changing as time goes by, I'll give it a name. I'll call it x. Can somebody just relax, kick your feet up, and give me a relationship among the three sides dx and the one whose length is 5 feet? I think so. So by the law of cosines. I think the square of that length d is equal to the sum of the squares of the length of the individual legs, which are 5 and x, minus twice the product of 5 and x, times the cosine of the angle in between. What's the angle? I can't read it. Yes, 150 degrees, isn't it? That's the angle interior to the triangle. So I think d squared is equal to 25 plus x squared. I don't know what else is left. Is it a plus 5 root 3 times x? Well, the cosine of 150 degrees is negative root 3 over 2. I was canceling my 2's. Well, that being the case, since x and d are both changed in respect to time, then differentiating with respect to time t, I'm left with a 2d dt being equal to my 2x dx dt. Oh, no, I can't write it. Yeah, don't say that fast 3 times, it never works. Plus my 5 root 3 dx dt, and I'm getting too sloppy again. Hold it. That's a plus sign. It's time to take a break and see if I have everything I need. I'm trying to find d dt. So plugging everything else in that I know. For example, after 10 seconds, oh shoot, what is x after 10 seconds? I asked, what is x after 10 seconds? 20 feet. Times dx dt, which is
2 feet per second.
positive 2 feet per second. I'm going to add that to 5 root 3 times my dx dt, which again is just 2 feet per second. And we're in business. Now I just have to number crunch, correct?
No.
No, I'm not done.
Where's the d?
Actually, this is not working because technically speaking, I don't have a d value. So I got to take a break. And taking a break, I'll pull out a piece of nifty scratch paper. And at this one point in time after 10 seconds, I think here's the corresponding triangle I have. Here's my b. Here's 5 feet. Here's 20 feet. Here's my 150 degree angle. Yet again, by the law of cosines, I think d squared is equal to 5 squared plus 20 squared minus twice the product of those two pieces times the cosine of the included angle. But that just simply means d is equal to the square root. Hoi, yoi, yoi. Is that 425 minus? You guys are going to help me again. Is that 100? Root 3, but it's plus, not minus. Or shall I say, d is nothing more than 5 times the square root of, that's 17, plus 4 root 3, I think, I hope.
So if we could show that the step of us finding the length of d, that's not, like we have to show that aside, like we could just,
Do it in your head.
well, just do it on calculator, I guess. Like, or would we get dock points if we didn't?
I definitely wouldn't want to see something that you computed instead of just using some program pre-existing.
Oh, okay.
Yeah, definitely. Oh, now I got it, I can put it in. I guess that means on the left-hand side, I've got a 10 root of 17 plus 4 root 3. You guys can stop. Now it's just a piece of cake. Isolate the d. That wasn't bad, was it? Seriously.
If we, like, didn't put it in exact, the value of d, if we put it in decimals, would that be?
Yeah, that's why I was saying at the very beginning. Give me exact
Oh.
things, unless otherwise stated.
Sure.
If that is okay, someone said number 5.
Yes,
Oh, one other fun one. I like these questions. So, back to number 5. I've got an open box. I'm sorry, I missed. I meant to say, I've got a box with an open top. in a square base, its surface area is fixed at 100 square inches. And I want to determine the dimensions that will maximize the volume. You guys, if I try to maximize the volume, that's what I want to concentrate on in terms of the formula. Yes?
This is not number 5.
I'm sorry, you guys. When I typed up my solutions, I changed them before I sent them to the printer. I apologize. Which one's yours?
Well, it's just the area and the volume are flipped. So it's the volume's fixed at 100.
I think you're looking at number 6 instead of number 5.
Gotcha. Oh, is this the cost one?
Yeah, $2 per square inch.
I apologize, you guys. Can I come back? I want to erase the picture. It's the same picture. However, the cost of the bottom is going to be at a rate of $3 per square inch. The cost of the lateral sides is going to be $2 per square inch. And I also have the volume is fixed at 100 cubic inches. And I'm trying to determine the dimensions that will minimize the total cost. And if I want to minimize the total cost, I think I just want to write a function giving me total cost. And so you guys, check this out. The cost of building the bottom is nothing more than this area times the unit cost, which is $3 per square inch. And I think the cost of one of the lateral sides is going to be its area of one of those lateral sides times the unit cost, which is $2 per square inch. Oh, but shoot, I've got 4 lateral sides. I better multiply that by 4, and I better add that to the cost of the bottom. And I am very unhappy this semester. In 2 semesters, I'll be happy again. Right now, I'm unhappy because I can't do functions of more than one variable. And so, given that I don't have the tools of the multivariable calculus, I have no choice, you guys. I got to take a break. I got to take a break and try to find some kind of constraint relationship between x and y. And building such a constraint relationship, relating y to x, I can solve for y in terms of x or vice versa. And I think here's the information that's given that allows me to build that constraint relationship. Because I think the volume of any rectangular box like that is nothing more than the product of its length and its width and its height. It's just in this particular example that the volume was fixed at 100 cubic inches. Oh, look at that beautiful equation. This allows me to relate y to x. Actually, I can solve for y in terms of x quite easily. I'll just divide both sides by x squared. Now I'm happy, because when I use that relationship, come back over here, and rewrite the entire right-hand side solely in terms of the variable x, you guys, look what I've accomplished in terms of a task. I've literally built for myself now a function in one variable, namely x, that gives me the total cost of constructing such a box. Perhaps allow me just a brief moment to first use my Math D skills to clean that beast up a little bit. Is that a 3x squared? Is that an 800 over x? And now that I've cleaned up the right-hand side of the equal sign, let me dive in and use my tools of the differential calculus. I will differentiate. Oh, by the way, in this example, that's a piece of cake, isn't it? C prime of x is equal to a 6x minus 800 over x squared. Massage it. Clean up a tad bit. And to determine where my local extrema are, or what values of x actually give me local extrema, I'll simply build a sign graph. And I'll plot all my critical numbers. Downstairs I've got a 0. Upstairs I get the cubed root of I don't know. Is that 2 times the cubed root of 100? All over.